remember the alpha 4. Alpha 4 is a fraction. It's defined as the y minus 4 to the total EDTA. So we talked about that in a previous lecture, right? So review that. So this all depends on the pH, the proton, okay? So with alpha 4 defined like that, then you can plug in the pH, pH 10, then the proton is 10 to the minus 10, okay? And John?
How come you keep saying it depends on the pH, but in your previous equation, you had all, how do you say it? You had -1, -2, -3, like all in the same batch. Like, I mean,
that's what all the Ka values come in. Okay. So the alpha 4 was defined and derived in a previous lecture. So remember to review that with all the Ka values incorporated. Okay, so now it's H4y. So you're going to involve 4 Ka values. So review that. And alpha 4 will then be simply calculate with this. Okay, so Ka1, Ka2, Ka3, Ka4. Okay, and plug in the pH. So once you get the alpha 4, then this one, right, alpha 4 is defined as that, and therefore you will get this by multiplying alpha 4 to the total EDTA, CY, yeah?
Yeah, I'm sorry, just one more question.
Okay.
No matter where we started on the scale, like from the neutral all the way down to the -4, we will always have all those Ka values incorporated into the equation.
Right, as long as you calculate for alpha 4, this is it.
Okay.
Yeah, the 4 meaning you're going to use all the K4 eventually. Yeah, Chris?
The CY is the starting concentration of EDTA?
Look at the previous one. Maybe I should just stay with this screen.
You didn't expect questions there, did you?
Notice this is at equilibrium. Okay, so at equilibrium mixture, this is your total EDTA. This is what you started initially. Okay, this total is going to complex the majority. Okay, the left behind at equilibrium will be distributed into this species. So this is what is left behind.
So the unreacted EDTA.
Non-reactive.
Yeah, okay.
Okay, or at equilibrium. Yeah. Okay, so be careful looking at the definition. So now with this CY known, then you can calculate what portion of this is from the CY. This is only a portion of it, okay? Which makes sense, right? This is the free 1, 4 minus. So come to this one here, then what is the fraction now? Is alpha 4. So it's defined as pH dependent, right? Otherwise you would not know the combination of H to the Y. Okay, it's because of the availability of the H. So here is the availability of the H. Okay, so alpha 4, you plug in pH equal to 10, then H is 10 to the minus 10. So now you get alpha 4 from this. So you want to know the portion belong to 4 minus from the total right here. So alpha 4 is going to multiply that. right? Alpha 4 multiply that. Okay, so now we can use the equilibrium constant. What is the meaning of equilibrium constant, right? At equilibrium, you do the calculation. Okay, so everything is at equilibrium now. Okay, so this is a complex quantity at equilibrium. And here is how much of that is left at equilibrium. And here is this quantity at equilibrium, okay? Okay, so the usual definition is, right, the complex over calcium 2 plus over Y4 minus, right? So instead of writing Y4 minus, we write the equivalent of alpha 4 multiply Cy, okay? So this is same as that. So that's in line to the definition. So now you can proceed with the calculation, okay? So alpha 4, the rest is algebra. Alpha 4 moves to the left. Then as long as you know this, then you can calculate for that, okay? But then formation constant multiply alpha 4 is so-called K prime. K prime is the conditional constant. Depends on your pH. So it depends on the alpha 4. Well, for a particular complexation system or reaction, you will get a table available between calcium and EDTA, then a different pH, pH 6, then you get an alpha 4 value, pH 10, you get another alpha 4 value. So this alpha 4 in practice, you can look up the table. Unless for exam, I ask you to calculate that instead of using the table. Okay, yeah, Mr. Lowe.
Okay, wouldn't your y to the negative 4, wouldn't it just equal your K1, K2, K3, and K4? Because if your alpha 4 is equal to y to the 4 over Cy, right? And then we have that, and then it's equal to K1, K2, K3, K4 over your total concentration, right? And if in that equation right there, the calcium over right here, yeah, if alpha 4 and Cy are equal, wouldn't the Cy and your alpha 4
So look like you and Chris have the same question. What was it? So your answer is here, the same answer that I did with Chris' question. Now, accept this by understanding it. Your total EDTA now sum is going to complex, right? This has no
Oh
problem.
yeah,
right?
I understand that.
Now this Y4 minus is a portion of all these species. So this whole deal is Cy. Notice plus Cy. So this is a part of that. So keep that in mind. This is only a part of that. Okay. So that part is pH dependent, right? Depends on how much proton are available. So higher or lower pH will affect all these quantities, right, associated with the proton, okay? And that's why you need to calculate based on the alpha, which is alpha 4, okay? So be sure you understand this and accept it, okay?
And accept it?
I don't accept it, I memorize it. Well, this is at equilibrium, right? This is what happened, right? Yeah, the total. Okay, Chris?
Or I
Yeah,
think-
long
alright,
time
so
ago,
it's-
you accepted it.
So you have the one salt that breaks down to 4 different products, right? Or the EDTA that dissociates into the 4 different
pH
ions,
dependent.
right? Okay. And then what we're looking at is because we want the -4 ligand, we're looking to see how much of that is inside all the products that dissociated, right? And then
Well, yeah, because of this, right? You're looking at it, the KF is defined with this species complex with that species at equilibrium. So this is what you must look at.
Right,
Yeah,
okay.
in order to get this species, experimentally you adjust the condition to get this. So pH 10 will get that.
Because
Then how much do you have? Then you calculate alpha 4, for decision, for
And
determination.
that's the part that's gonna be going back and forth. and
That's right.
And that's how we're,
But then your pH cannot be higher than 10. If that's higher than 10, your calcium will precipitate off from solution, even though you get virtually all the EDTA as 4 minus. But then what good does it do when your calcium precipitate from solution? So that's a limit. So it turns out that pH 10 is a good buffer to use and generate enough of this for complexation.
so then you're just multiplying the formation by the ratio of the amount.
That's
of
right.
free
Alpha
ones.
4 is that ratio.
And that's how you get the K prime,
Yeah.
the adjusted
Yeah,
formation.
yeah, that's right, that's right. Okay, I have 4 examples in calculation, so you understand that point better.